In this assessment, we're asked to predict the product of the ether here reacting with two equivalents of HBr. Now, HBr is a really strong acid. The ether oxygen has two pairs of electrons that it can use in an acid-base reaction. And so we'll start by protonating that oxygen. When we protonate the oxygen, we've made a molecule that kind of looks like a protonated, like a water molecule contained within. That is to say, we've got a good leaving group. And what do good leaving groups do? They leave. So this oxygen, wanting to become neutral, is going to pull this pair of electrons away from this carbon. Why have I chosen that carbon? Well, I've chosen it because the carbocation that we make here is going to be stabilized by resonance. The other product of this reaction is this alcohol. We'll come back to it in just a second. Once this carbocation has formed, though, now Br- can react with that carbocation to give our first product of this reaction. Note that because Br- is attacking a carbocation, a planar carbocation, it can attack from the front or the back, and as a result, we'll end up with a racemic mixture of alkyl halides. What about the second equivalent of HBr? Well, we have this alcohol. We know that alcohols react with HBr in the same type of acid-base reaction we've already shown. That's going to give us a water molecule contained within that. Once again, a good leaving group. Good leaving groups leave, so water is going to leave to make this secondary carbocation. And now this secondary carbocation can react with the bromide nucleophile to give the alkyl halide, the second of the two products. So the two products in this reaction, this alkyl halide and this alkyl halide.